Okay, so the first part of today's opener, we worked on Monday and Tuesday. We're going to factor each of the following, then we're going to write our factors in standard form, then write it in exponential form. Now, when we first started this lesson, we talked about prime and composite numbers. Who can tell me what is a prime number? Kelly? It only has two what? What's that new term that we were talking about? A prime number only has two, starts with an F. Factors, okay? A composite number has more than two factors. Now remember, factors are numbers that you can multiply together to get the product or the answer. So for 60, we're going to go ahead and factor it. So there's all kinds of factors that you can use and multiply together to get 60. If I use one and Alex uses another one, it's okay. Because when we get our prime numbers at the end, that's what matters. So what two factors do you guys want to use for 60? Huh? 2 and 30. Okay, how many of you guys use 6 and 10? That's totally fine. Keep factoring 6 and 10. Oh wait, now 2. Can I factor 2? Yes? What times what? That's a guess. But no, I can't factor 2. I could.
1 times 2.
1 times 2. But if I put 1 times 2, I can put that on and on and on and on forever, right? So 2 is considered a prime number. My prime numbers, I circle. So whatever I write down up here, you're going to write down on here. So since 2 is a prime number, I'm done. I can't do anything else with this. So I'm going to move to the 30. Can I factor 30?
15 times 2 and 10 times 3.
Okay, so you could use 2 times 15, or you could use 3 times 10, or you could use 5 times 6. Any of those factors are okay. I'm going to use 2 and 15 because that's the first thing Michael said here. Now, because my 2 is a prime number, I circle it. I am now done with this. So I go to my next part of my factor tree, my 15. What are 2 factors I can multiply together to get 15? Jair? 5 and 3. So I have my 3 and 5. Does not matter if you put the 5 first or the 3 first. I just like things in order. And they're both prime numbers, so I'm going to circle them. Now, because I've circled all my prime numbers, I have no other numbers left to factor. I know that I am finished. So I'm going to come up to the right of my 60. The first thing I'm going to do is I'm going to put an equal sign. It's going to be really important to have that equal sign to show me where I'm putting in my first answer. Now, standard form is where I write the numbers that I have circled, my prime numbers, in order from least to greatest. So if I put my numbers in order from least to greatest, Daisha, what is it going to be? Standard form. What comes before the 5? There you go. Times. So there we have it in standard form. The second part of my directions say write it in exponential form. So Alex, how would I write this in exponential form? How many 2's do I have? So I'm going to put 2 squared times how many 3's do I have? Just 1. So I could put 3 to the first, but that's extra. I don't really need it. Times what? 5. Perfect. Good. So when I go to grade your quiz on Friday, you're going to get a point for showing me this. You're going to get a point for having this in the correct order, and a point for having that written correctly, and then a point for your box. Okay? Let's take a look at 45. Jalen, what 2 factors can I multiply together to get 45? Don't tell me you don't know. You have a multiplication chart you can use that I told you to get out? Well, if you tell me you don't know, I'm giving you some resources to help you know. So what 2 numbers can you multiply together to get, say it again? So close. 5 times 9. There you go, much better. So 5 times 9. Jalen, can I factor this 5?
No.
Because it is a... So I'm going to circle it. Good. Can I factor the 9?
Yeah.
Okay, what times what?
3 times 3.
And can I factor my 3's? Because they are? Good. Nice job. Come up to the right, I put my equal sign. Danielle, standard form, how would I write my prime numbers here in standard form?
3 times 3 times 5.
And then exponential form, Kyle.
I was doing the other.
That's okay. Go ahead and look up here. How would I write 3 times 3 times 5 in exponential form?
Oh, 3 to the second times 5.
Good job. So you might want to fix this one. Any questions on those first two? Okay. Moving right along then. So let's drop down to 128. Now 128 is a little bit of a bigger number, right? Danielle, he has really good handwriting too. Make sure you box both your answers here. So you can always glance at Danielle's too. So 128 is a little bit of a larger number. It is on your multiplication chart, but if you don't like to use a multiplication chart because you're stubborn, how can you find what a factor of 128 is going to be? What number can you use in 128 to help you find a factor?
120 divided by 1. Well, 28.
128 divided by 28, will that work? I don't know. Well, I always look at my last digit. What's my last digit? An odd or even number? Is an 8 odd or even? Even. And all even numbers are divisible by what? 2. So I would take 128 and I would divide it by 2. 64. So I know that 2 times 64 will then get me 128. Or you can use 8 and 16. They're all different kinds of factors that you can use. Now you guys told me on the previous problems that 2 is prime, so I'm going to circle it. So here I'm going to go to 64. What factors can you multiply together to get 64? Or what numbers can you multiply together to get 64? Anybody? 8 and 8. Okay. Can I factor 8? Yeah. What times what equals 8? 2 times 4. We know 2 is prime. Can I factor 4? Yeah. What times what? 2 times 2. And I know that those are prime. Am I done with this one? Am I done with this whole part of factoring?
No, you need to do
No, I got one more 8 to do, don't I? So I'm just going to do the exact same thing here. 2 times 4. And 2 times 2. Good morning. Ooh, I have a whole bunch of prime numbers here now. What do you notice about all these prime numbers? They're all 2s, right? How many 2s am I going to have to write out in standard form? 1, 2, 3, 4, 5. You sure? Count them again. 7, right? That's where, like, I honestly, when I have a lot of numbers like that, I will go through and cross them out as I do them to make sure that I get them all. So I'm going to write 7 of these things out. 1, 2, 3, 4, 5, 6, 7. Now, if I type that into my calculator, 2 times 2 times 2 times 2 times 2 times 2 times 2, what is that going to equal? What should it equal? It should equal what? 128. Yeah. Okay, so standard form, I had to write out lots of 2s. Exponential form will be a lot easier to write and easier to read. How would I write this in exponential form? Yeah, 2 to the 7th power. And then box the entire thing. Make sure you have your standard form boxed and your exponential form boxed. So put a box here. You need to fix that because 4 is not a prime number. Okay? Remember, I've seen it out of all my 4 classes yesterday. I have seen at least 2 kids in each class that do not factor 4, and they count 4 as a prime number. 4 is not a prime number. You can factor 4. All right, 1,000. What 2 numbers can I multiply to get 1,000?
110.
So 10 times 100. Okay? Jair, is 10 a prime or composite number?
Prime.
So I can't factor it, it only has two factors?
No, it-
2 times.
Composite.
Because
So what are your two factors of 10?
5 and 2
Okay. And is 2 prime or composite?
prime
So I circle it. What about 5?
composite.
Can I factor it? Okay, if I can't factor it, well, I can say 1 and 5, but it doesn't have any other factors, does it? So, yep, it's prime. Okay, 100. What? And I don't want, for 100, I don't want the factors to be 10 and 10. What are 2 different factors I can use to multiply together to get 100?
25 times 4.
Good. So let's do 4 times 25. Can I factor 25? Is 4 a prime or composite number? I just told you guys this. Is 4 composite, so I can factor it. What times what equals 4?
2
And those are prime, so I'm going to circle them. If I go too fast, you guys have to tell me to slow down, okay? I know sometimes I get going. 25. What can I factor 25 with? Michael?
5 times 4.
How about 5 times
5.
5? There we go. And is 5 a prime or composite?
Prime.
So I'm going to circle it. Who haven't I not heard from? A lot of you guys, but who do I want to pick on?
You can pick up that teacher right over there.
Mr. McFarland,
Yes, ma'am.
write these in standard form for me, please.
All right, we have, let's see if I can see that far. 2 and 2 and 2 times 5 times 5 times 5.
You guys check his work. Is he right?
Yeah.
Yeah? Okay. And let's see, Michael, now I'm picking back on you because you picked on a teacher. How can I write this in exponential form? Look up here. How many 2's do I have?
3.
So I'm going to put 2 to the 3rd power times, how many 5's do I have?
5 to the 3rd power.
And box the entire thing. All right, backside. This is where the fun really begins.
Already done it.
How many, I flip it over again. But I'm going to have you write your answer in a specific way because I am picky. You guys know this at this point, right?
Piggy's only for food. And you're
Picky, not piggy. Well, if it's cupcakes, I'm piggy. Okay,
Me too.
so we have square roots. What we're going to talk about today. So I want you guys to find the square root of 81. Now your calculator can do that for you. So if you type in the square root of 81, what are you going to get? If you don't know how to type in the square root, let's take a look at it. Let's see here. It's been a year since I've used the square root button. Okay, so 81 seconds. So what you'll hit to type it into your calculator, you're going to hit your second button, your x squared button, because above that x squared button is your square root button, and your equals. Ooh, I lied. Hold on. Second, 81 equals. There you go. So you'll hit your second button, your x squared button, and then 81 and equals, and that'll give you what the square root of 81 is going to be. What is the square root of 81 going to be?
9.
9.
See, already got it. Already got it.
So you're going to put 9, and you're going to box it. So this next part is going to be pretty easy
6.
if it's a perfect square. So what's the square root of 36?
6.
Okay. So Michael, don't answer this one.
Alright.
Oh, you can't answer this one. So you'll do second, this button, because that's your square root sign above, 81 equals. There you go. Okay, now this next one looks kind of funny. We have the square root of 13 squared. So before we can really address this, we need to talk about a couple of things. Inverse operation. We talked about inverse operation the very first week of school. When I say, what is the inverse operation of addition, what should you guys say? What's the inverse operation of addition? The opposite. What's the opposite of addition? Subtraction. They cancel each other out, right? So if I put an addition sign, the inverse operation of that is subtraction, meaning they cancel one another out. What's the inverse operation for multiplication? Division. They cancel each other out. What's going to be the inverse operation for square root? What do you think is going to be the inverse operation for square root? What's going to cancel a square root out? We haven't put that aside. So what's going to be the opposite of a square root? What is going to cancel a square root sign out? Well, if you look at your opener on the example number 3, what does it have different that the other two problems don't have? A square. So square and square root, they're the opposite of each other. They cancel one another out. Okay? This is going to be something that needs to stick in your head. You have to remember that square and square root cancel one another out because you are going to have to know that from this day all the way until December. Okay? So if I come down to the square root of 13 squared, what did I just say about square and square root? What do they do to one another? So if this square cancels that square root sign out, what am I just left with? 13. That's it. That's my answer.
Ooh,
Now the
I
last
am
one.
smart. Look.
Now the last one. The square root of 50. If you go and type into your calculator the square root of 50, are you going to get a perfect square?
No.
These here are perfect squares where it worked out perfectly. I don't have any decimal. Jalen? Jaden's not teaching the class, is he?
No.
So there's no need for you to turn around.
JJ.
I need you to stop with the talkouts. Okay? So type into your calculator the square root of 50. Everybody, type in the square root of 50, and what do you end up with? Jair?
7.07.
7.07. So the square root of 50 is going to be between 7 and 8. And we're just going to leave our answer like that. We're going to actually talk about, and what we're going to do next week, when you get the square root of 50, you guys are actually going to have to factor it out. So next week, when you guys get that and it becomes a decimal, you guys get to do all this fancy stuff with it. You don't have to write what I'm writing right now. But this is what you'll do next week. This is why I'm teaching you how to do the factor trees now. That's what the answer should be. So, remember how I said Monday, Tuesday was going to be a building block? Wednesday we're going to add on? Next week, you're going to combine Monday and Tuesday's lesson with today's lesson to get this lesson. Okay? So go ahead and get your names on the openers and pass them towards Mr. McFarland.